Hey, what's going on everyone? Michael at Paragon Armory. I'm going to be talking to you guys today about tappet plates. This is a pretty overlooked part in a lot of builds, but it's actually very, very important to get this part right for shot-to-shot consistency, as well as just overall performance in feeding and cycling. Going to be talking about this guy today, how to tune it, what to look for, and how to make your gun shoot better. So in order to do that, let's head over to the tech bench and see what we got going on over there. All right guys, so we're over at the tech bench and I have some tappet plates laid out in front of me. I would say the most important thing to do is to select the optimal tappet plate for your application. Obviously that means matching the version with the version gearbox you're working on. So if it's a V2 gearbox, you want to make sure you get a V2 tappet plate, V3 gearbox, V3 tappet plate, so on and so forth. I know it's common sense, but I just want to make sure that it's covered. But in terms of choosing the optimal tappet plate, what I mean by that, there's three things that I'm particularly looking for in a good performing tappet plate. First things first, it has to be strong. Okay, so that really doesn't count. We always want a strong tappet plate because we don't want it to break, but that's kind of just like a no-brainer. So the first and most important thing for me is actually going to be the tappet plate angle and nozzle angle. So that means this L shape here, we want that to be a perfect 90 degrees. With certain tappet plates, you're going to see some that have a less than 90 degree angle, and what that does is that it tilts the nozzle upward. And this exacerbates the issue with mid-cap syndrome, feeding and FPS inconsistencies, as well as accuracy inconsistencies because the nozzle is tilted upward and sometimes not chambering the BB correctly. So we want a tappet plate that has a perfect 90 degree angle. Okay, so along with the angle, we want the nozzle to have a snug or secure fitment between the nozzle and the tappet plate. And in some cases, you're going to have tappet plates that are a bad match with certain nozzles. So something to note here is that this FPS Software tappet plate that I have in my hand doesn't really like other nozzles other than the FPS Software from my experience. So for example, I have I have a VFC nozzle here in my hand, and while it does fit, it actually is very loose. So this comes off super easy, and that's not something that we want to happen when we're matching our components. There is a workaround for this. I've seen people use Teflon tape and they go around that little groove there to make it a snug or secure fitment. And I've also seen people using some form of glue. If you're using glue, just make sure it's only going to be on this groove here and it doesn't go inside the nozzle. Okay, and that can go for any other combination of tappet plates as well. If you want to try to reduce that wobble, I would try the Teflon tape first because that's reversible. The glue, not so much, okay? So again, guys, I would say to avoid having to deal with any of that modification, just get a tappet plate nozzle combo that is gonna have good fitment from the get-go, okay? The next thing is gonna be the tappet plate fin shape. So all three tappet plates here have different fin shapes. I would say my favorite fin shape is actually the garter shape here. The reason for that is it has correct timing for most sector gears, so we're going to get into the timing aspect of it. But another thing that's good about it is that it keeps the nozzle in an open bolt system for a longer amount of time than usual. So what that means is the nozzle is going to be retracted longer, and what happens is when you do a magazine change, the nozzle is going to be retracted, allowing a BB to immediately go into the hop-up chamber and to be fed for the next shot. So that is a good thing about the garter tappet plate. But like I was saying with the nozzle and tappet plate angle, the garter tends to have an issue where the tappet plate is actually less than 90 degrees. So on the garter, for example, you will need to apply some heat to this corner here, either through like a hairdryer or a heat gun, and then slowly bend the nozzle back to 90 degrees to correct for that issue, okay? You can use the edge of a table, you can use your hands to kind of bend it. I would probably use the edge of a table to get it back to perfect 90 degrees. So to recap, we're looking for a 90 degree angle for nozzle centering. We want snug nozzle fitment, so that way it doesn't wobble when it's cycling back and forth in the gearbox. And then we want a good fin, because this determines the feed window and how the nozzle and tappet plate move inside the gearbox in correlation with the gear set. The fin stuff will make more sense once I get that contraption over here and I show you guys tappet timing. All right, so let's move on to tappet timing. To understand what bad tappet timing looks like, I'm going to show you. So this is a Prometheus perfect tappet plate. So it checks off a couple boxes in that the angle is a perfect 90 degrees and it holds the nozzle very secure. So you're gonna have optimal nozzle position, meaning the nozzle is gonna be dead center of your cylinder head in relation to the hop-up chamber if all of those other things are installed correctly. Okay. The downside to this tappet plate is the fin shape here. This one would definitely need modifications in order for it to feed properly in this case. So let's just go through the cycle manually. And this is how I check for all of my tappet plates and tappet plate fin profiles as I do this manual check here. This is the sector gear cam. So what we're looking for in correct tappet plate timing is we want the tappet plate to start retracting shortly before the piston is starting to get pulled back or retracted, okay? We don't want it the other way around. We don't want the piston to start being retracted before the nozzle, because this can cause some FPS issues. Okay, so in this case, the tappet is being retracted before the piston is starting to move here. Okay, all right, so right there, the nozzle is pretty much fully retracted, and now the piston is starting to pull back. So let's go through the rest of the cycle here. Okay, nozzle is still retracted. Nozzle is still halfway retracted. So right here, the piston is already moving forward. And the nozzle here, you can see there's a gap in this part. That means the nozzle hasn't fully moved forward yet. Okay, so it's got some more time to go there. So what happens there is you've already gone through your compression stroke here with the piston and the piston head, but your nozzle isn't forward. So in this case, your gun wouldn't feed. The way to correct that would be to modify this tappet fin for it to release sooner in the cycle. And typically what I look for in that case is I want it to release either by the second or right before the last tooth. So right here is where I would need that tappet plate to release. So you could take a pen or something and you can mark that area. So let's say, for example, I want it to release here. I would need to mark the area in which it stops making contact with the sector gear cam, so that way the tappet plate could move forward, okay? So let me show you what correct tappet timing looks like. So over here I have a retro arm CNC tappet plate that I've modified. So the pickup area is filed back slightly. That's just because I want the tappet plate to pick up a little bit closer in relation to when the piston gets picked up. So over here we have full retraction of the tappet and the nozzle, and that's when the piston is starting to get picked up. So we're looking good there. We're going through the cycle. The tappet is slowly starting to cycle forward. And right here, you can see the nozzle and the tappet are now fully forward. Okay. Now it's fully forward. But I still have, I'm holding the sector gear here to show you guys that it's still being held by one tooth. So it's got one tooth left to be pulled back, and right there, now the piston can move forward. So the nozzle was fully forward by the time the piston can do its compression cycle. So that's what we're looking for. And you can kind of get creative with this, guys. I know in the past, people have just chopped the height of the tappet fin in order to change the timing of the tappet plate. But lately I've been playing around with different shapes and ideas because the concept that I want to maintain is I want the tappet plate and the sector gear cam to maintain contact throughout the whole cycle. So if we pay attention here, the whole time the sector gear is moving, you can see the fin is still making contact with the cam there, even by the time it's fully forward. So right there it's fully forward and it just let go of the cam there. And the reason behind that is we want to control the smoothness of the tappet plate cycling. When you have a smoother cycle of the tappet plate, you're going to see better consistency in your BB chambering. And that leads to better shot-to-shot consistency, can lead to better FPS consistency, and so on and so forth, rather than the tappet plate just flying forward without any support at all. So try to keep that in mind, guys, when we're modifying these fins here. We want the tappet plate fin and the cam to kind of ride home together. So another thing to consider when installing tappet plates is the spring. Now this is the FLT Enhanced Tappet Plate Spring. This has been my go-to spring for the last few years now, since he sent me these as a prototype in the beginning. These have worked phenomenally well in high-speed SSG and DSG setups. With a stiffer spring, you're going to have a faster cycle rate of the tappet plate here, and this can help combat mid-cap syndrome, because what happens with mid-cap syndrome is a couple things. So you have the BBs coming from the bottom and they're hitting the nozzle here. So another reason why we want a stronger fitment, or a more secure fitment between the nozzle and the tappet, is because we don't want the nozzle to shift upward, because BBs are resting on the bottom, kind of pushing the nozzle up. So that's one reason. The other thing is, with a stiffer spring, you're able to overcome that resistance there, because what happens is that it causes friction on the bottom of the nozzle. The spring helps overcome that friction, so that way you can get the nozzle where it needs to be in the correct amount of time. If you had a very weak spring, what will happen is the cycle would be very sluggish because of the friction caused by the BBs underneath. While the tappet spring can help with mid-cap syndrome, it is not the silver bullet. It is a part of that equation. So like I said, if we're encountering mid-cap syndrome, we need to make sure that the nozzle angle is correct, and that starts with having the correct angle of tappet plate, perfectly 90 degrees. We want good fitment of the nozzle to tappet plate. We want to make sure that's secure. And if we have a bad mismatch of parts, we need to make some modifications in order to make that more secure, either through Teflon tape or through glue. I personally do not prefer those methods. I prefer just to get the correct tappet plate off the rip. In this case, the Retro Arms has probably the best fitment out of any tappet plate that I've ever used, and this is why I will continue to use that until something better comes along. Nozzle fitment, nozzle angle, as well as cycle speed from the spring are going to be what helps combat mid-cap syndrome. Now, there are other things outside of the internal parts of the gearbox that change alignment with the gearbox itself, but that will be for another video. We're just going to be talking about the tappet plate stuff today. Alright guys, and something else I want to quickly address too is SHS style or rocket style sector gears. They're a little bit different than your standard SeachTech sector gear. So if we have these side by side here, the SeachTech has a built-in delay cam, and the timing is already set for the gear itself. Now I've noticed with SHS and Rocket, depending on when the batch was made, this sector gear pin cam or whatever you want to call it, can be in different positions. So you kind of have to account for that as well. Again, we can always do that manual check of, okay, is the cam picking up the tappet before the piston? Yes, it is. The only downside to this design is that your tappet isn't retracted nearly as long. So as you can see here, the tappet is forward and we're about 75% through of the piston cycle here. So if you're finding that BBs are not traveling up into the chamber all the way and we're having feeding issues there, And that's when we can consider something like a sector delay chip. And this is one that I particularly like to recommend. This one is from FPS Software. The model on this one is the DL03. The reason why I like this one is that it adjusts the timing in a way where it's not messing with the pickup. Some delay chips advance the pickup so much that the tappet is being retracted again before the piston has actually fully compressed. And that's not good either. So let's get this in here and then we can see a visual representation of what I'm talking about. So now we got the delay chip in there and we can see the tappet being picked up, and then by the time it's fully retracted, the piston is now starting to do its cycle. But now, as you can see with the delay chip here, it's retracted for a bit longer. Okay, still retracted, and about here is when the nozzle is fully forward. We have about 3 teeth left for it to do a full cycle, and boom, it's done its cycle. So now I know there's going to be some people in the comments saying, but Michael, I have a DSG. How do I tune my tappet plate for that? Well, don't worry guys, I've got you. Got a DSG gear here, so let's go ahead and get that installed. Okay, and for those who are not familiar with a DSG, that just stands for dual sector gear. So this one has teeth on only at one side of the sector gear. This one has teeth on both sides. So this one will have 8 teeth. This one originally starts with 16, but this one's been short stroked. So with the dual sector gear, what we're able to achieve is a faster cycle rate because you're going to be picking up the piston technically twice as fast, but the piston is only going about halfway. Okay, so you can see it's only going halfway because it's only 8 teeth and it's moving forward. There are going to need to be some modifications done to the tappet plate in order for the system to feed and cycle correctly. The same concepts will apply. We want the tappet plate to start retracting before the piston starts to retract, okay? So in this case here, with this tappet plate, all right, we've got nozzle and tappet retraction shortly before, like almost at the same time, I would say milliseconds before the piston gets picked up. Okay, so we're going through the cycle, okay, and boom. And right here, the piston can move forward, like that. But our problem is that the nozzle is still in a retracted state. So it's done its compression cycle, but the nozzle isn't forward, which means it's not going to send the BB out of the barrel. So what do? Well, in this case, we need to shorten the tappet plate fin in order for it to start moving forward. Now, Siege Tech has a PDF document that you can view online, which details the measurement in which to cut the tappet plate, and that's a good starting point. Like I said, I've been experimenting with different fin profiles because I want to maintain that philosophy of a smooth nozzle cycle, okay? So I've got this tappet plate fin here, and it looks a little funky because it's got this weird angle there. And you're going to see what I mean in just a moment. All right. So here we've got the tappet plate starting to get pulled back and retracted. And right there, we're going to see the piston start to get retracted as well. All right. We've got about 2 teeth left, and now the tappet plate is starting to retract. Or not retract, excuse me, it's starting to cycle forward, okay? And right there, the tappet plate is fully forward, and we have about a tooth left for it to make its cycle. Let's do it again, okay? Right here, starting to pick up the tappet. Okay, piston is picked up and is doing its cycle. Right about here. Okay. So right there, the nozzle is fully forward. Okay. And now the piston can do its full cycle. Let's do it one more time. So if we pay attention to the cam here and the tappet plate fin, we can see throughout the whole cycle that it's actually following this cam home the whole way. And DSGs have a really bad problem because the fins shorten by a significant amount that the tappet plate just slams forward all the time. And what typically happens is you'll get micro vibrations at the end of the nozzle here, which leads to chambering, inaccuracies, inconsistencies, and things like that. And that's something that you're going to see as well when you're doing your range and accuracy test, is that sometimes with DSGs, at further ranges like 200 feet, 175 feet, your groupings aren't going to be as tight as, let's say, an SSG. And that's just because the BB chambering consistency isn't going to be as good on a DSG. So I've got one tooth to go. So right there, I can't move the piston forward, but you can see the tappet is able to move completely forward. So in this case, the timing would be correct. So we've gone through selecting the correct tappet plate. We know what to look for, and we've gone through the timing aspect of it. A few things that you can also check as well to make sure your tappet plate is maintaining correct angle is you can actually do a compression check here. So if I hold this forward, you can see that I can't compress the piston anymore. So I'm getting 100% seal from the piston head to the cylinder head to the nozzle, even in a fully forward state. Like, look at that. That is amazing seal. Now, if the nozzle weren't in a perfect position here, if it was off angle, you would possibly get an air leak from the O-ring nozzle, or the nozzle O-ring, excuse me. So just something to look out for there. All right, guys, that pretty much wraps up this video for tappet plate tuning. Hopefully that helped you guys understand the purpose of the tappet plate. Like I said, there's a lot of performance that can be extracted from the tappet plate system. But it just goes overlooked, guys. So this is something that can be easily addressed and easily tuned as well. All right, guys, a few last minute things to touch on. First one being fitment of the tappet plate inside of the gearbox. In some rare cases, the tappet plate can be a little too thick or too wide, which causes it to kind of like bind up and have some resistance inside of the gearbox. So an easy check for this is just to strip your gearbox and then only install the tappet plate with the nozzle and just close the two halves like that. And then just double check that your tappet plate cycles freely. So that's an easy test there. It's very rare. I haven't encountered it myself, but just something to consider when you're upgrading your airsoft gun. Tolerances are unfortunately a thing. Some gearboxes and tappet plates are made to different specs or tolerances. The next one as well is the sector gear height in relation to the tappet plate. So as you're shimming your sector gear, this goes up and up and up and up, closer towards the tappet plate. And in some cases, you can shim the sector gear too high to where it's actually rubbing against the tappet plate there, and we don't really want that. So just make sure after you've shimmed your gears, you put your tappet plate on, and you just double check to see that the sector gear isn't rubbing on your tappet plate, and you should be good to go there. Some very minimal rubbing is okay. It's not ideal. You can get away with it, but just try to reduce that as much as possible. I know in some cases you have to shim the sector gear higher than you would like. So again, just have to keep that in mind. Another thing that we can also visually inspect is the nozzle angle after everything is installed. So in this case, we would want the cylinder head, nozzle and tappet plate along with the tappet plate spring. And then you can just visually inspect the nozzle angle to see if it's perpendicular with this flat edge of the gearbox shell. What we want is for it to be, again, perpendicular, so this would kind of create a 90-degree angle there. and that would tell us if the nozzle is going to be in the correct orientation. Because if the nozzle was tilted up, then you're not going to get full air seal, and you're actually going to possibly get mid-cap syndrome because the BB isn't being chambered correctly, and you're going to have an air leak or a multitude of other issues. We need to address it here, make sure the nozzle is perfectly 90 degrees. Another thing too that we could check is how well the tappet and nozzle cycle. So this is like no lubrication, and it's pretty buttery smooth, which is a good sign. All right, everyone, that about wraps up this tappet plate tuning video. Hope you guys really enjoyed it. All these awesome parts you see in front of you are available on the website at www.paragonarmory.com. If you have questions on anything, please feel free, send us an email, send us a DM on Instagram. We are available to answer all of your questions for you. Really appreciate you guys sticking with me throughout this lengthy video about tappet plates. Really hope you guys learned something. If you guys can just do me a huge favor, like, comment, subscribe, really helps me out with the YouTube algorithm and makes producing these videos possible. So thanks again, guys. See you on the next one.